Hello guys, this is the Survey of Kenya. In today's video, I'll be showing you how to set out or to stake out using a total station. We'll be staking out a fountain that is meant to be built here. First thing we have done is that we have done a small topo of this area showing the buildings, the staircase, the tree area, the container and the wall because we do not want to interfere with existing features. I have drawn what I'm going to set out in my AutoCAD drawing and have shown all the features around. Let's go to the laptop and see the features and see how we are going to set out. After plotting the topo, this is what we have in an AutoCAD drawing known as fountain setting out. These are the buildings that exist in the area. This is our traverse 1. This is the brown wall to traverse 2. And this is traverse 3 that faces the container. We have a building here. We have a building and another building here. We have a tree area that we do not want to touch. And K1, K2, K3, K4, K5, K6 defines the fountain. You can see it does not touch the tree area because we do not want to remove the green in the area, and it touches nothing that is of significance. So we are going to go on field, and the first thing we're going to do, we will set our machine at traverse point 1, and then we're going to orient with traverse point 2, and then you're going to check whether traverse point 3 is correct. Now I will export the coordinates K1, K2, K3, K4, K5, K6. I can export them by IDing them. So I'll ID. And that's the northing and the easting, 98, 62, 976.37, 25, 85, 20.145. I'll do that for K1 to K6. And then I will use these coordinates to set out our fountain. So the first thing we are going to do, which I've already done, is to set our machine at traverse point number 1. Our occupation station is going to be traverse point number 1. We will orient with traverse point number 2 and check with traverse point number 3 to check whether our orientation is correct. Our machine is set at traverse point 1. We have known coordinates and we are going to add the known coordinates into the machine. For this project, I am using a South N6 Plus series total station, and this is how the screen looks like when you open the machine. We need to add the northings and the eastings of our traverse point number 1. So how do we do that? We go to menu, then we want to create a station, but for a new job. Now we're going to create our new job, new, the job name, and maybe call it coordinate. So coordinate, okay, success. Then okay. We are setting our machine at a known point. So number 1, known point, it's a new point. So new F2. And then the job you have just created, coordinate, okay. So point number is 1. And then its point description is traverse point number 1. So TRV1. Okay. I'll insert the northing, which is 98, 62, 982.79. The drop down, don't click OK, drop down. Easting is 25, 85, 20.80. We will not be using height for this job. Okay. So next, I want to set a backside, and I have the coordinates for the backside, so which is our traverse point number 2. So in this screen, I'll choose coordinate 1. It's a new point for the job, coordinate, okay. It's a point number 2, and its code is traverse point TRV2. We have the northing. We'll add the northing, which is 98, 62, 975.26, and then the easting, which is 25, 85, 35.34. Okay, saved. Next. Now my machine wants me to orient, so I'm going to focus on the prism, and once I have crossed the prism at traverse point number 2, I'll click orient. Now I'll have to focus at traverse point number 2 with my machine. Make sure I see the prism and have centered it. Once I am certain I have centered it, I'll click Orient. So I'll just move my prism to traverse point number 2. To get accurate results in this process, ensure that when you are setting the prism, it should face the total station directly. There's also one thing we also need to do. We need to level this bubble. The water should be at the center of this black circle. So I'll just level the water. I'll target the prism using this triangle here. So once I see the prism through the lens, I'll lock my machine using the adjustment knobs. I have targeted my prism. By target, I mean the crosshair that is at the center of the lens crosses the center of the prism. So once satisfied with the focus, I will click Orient. But before I click OK, I will measure the coordinate of traverse 2, and then I'll compare the coordinate with what I have on paper. The measured northing as shown on screen is 0.258, while the theoretical northing is 0.26 at 2 centimeters different, allowable. The easting is 0.343, while the theoretical coordinate is 0.34. That is a 3 millimeters difference. This means that our orientation is correct. I have checked the coordinates of traverse point number 2 and it was correct. The theoretical values matches with the measured. I'll click save. Now, once that is done, I will have to check with traverse point number 3, which I have over there, and see whether the coordinate that is in the book matches with the coordinate that I'll measure on the ground. We will repeat the process that we did in traverse point number 2. We are now at traverse point number 3, so we are going to level the water bubble and ensure that the prism faces the total station directly in a way that now I can cross-section the prism. Now we'll go to menu and we want to collect. We want to collect for the job coordinate. Ensure that your current job is the one that is open. Okay, I want to data collect. Now, I'll target on my prism, and once I am sure that I have targeted on the prism at its center, I'll measure. Before I save, I'll have to compare the coordinate that I have measured with the coordinate of traverse point 3 that I had. 98, 62, 958.22, this is 2137 millimeters error, 25, 85, 15.22, and this is 2191 millimeter error. We have successfully oriented our machine and we have measured the known point and checked whether the measuring is correct or the coordinates on the ground and the coordinates in the book reach the same thing. We have copied the points that we are going to stake out, K1 to K5, in our USB drive. Now we are going to insert this USB drive in the total station and stake out the points. I will insert the USB drive into my machine. Then go to menu, data. We want to import points to the machine. We will click import, call, setting out. Okay. Okay. Click OK to import the points. You can always view the points by going back. Data, data, coordinate data for the job coordinate. You can see the points. Here are the points. The points K1, K2, K3, K4, and K5. Once I am certain I have all the points K1 to K5 in my machine, I'll go to main menu, Stakeout number 2 for the job coordinate. Okay, guide light shines light in the direction of Stakeout. I don't need that. I want to stake out coordinates. Number 1, I'll call the coordinate I want to stake out and I'll start with K1. So I will scroll to K1. Okay. Okay. Once I find K1, okay, I'll stake out. Now, this screen is displaying a DHA, which means a change in horizontal angle. For us to find the line at which K1 falls, we'll have to rotate our machine until the change in horizontal angle gets to 0. And you can rotate using the fine adjustment knob and the coarse adjustment knob. Note here, the HD is reading the nothing. This is because I had also inserted the nothing in the place of Z, which is elevation, which I corrected. Note here, the HD is reading the nothing. This is because I had also inserted the nothing in the place of Z, which is elevation, which I corrected. Once the horizontal angle is set, I will take the prism and ensure that the chainman falls in the 0-degree line of the total station. Take this illustration for example. Assume that there is a light that is along that line. I'll need the chainman to move until that light falls on the prism. This is by directing them either left or right. Once that is done, I'll measure the prism and know the distance at which I'm supposed to move. At this point, you can direct your chainman to either move to the left or to the right. You can use your hands, or if they are close enough, you can use your voice. Once the prism now falls at the 0 degrees line, don't move the total station once it is set to 0 degrees. Once you can see them, ensure now they level the water bubble and the prism faces the total station directly. Now, you can see our DHA is 0 and the HD tells me to move 6.453 meters. I'll measure. Now, when I measure, it tells me to move far 3.303 meters. I'll direct the chainman along the 0 degrees line to move 3 meters behind, that is far. Once they have moved 3 meters away, I'll ensure that I can still see the prism. It is leveled and it is still at the 0 degrees DHA, horizontal angle change. Now, I'll do the same thing again and I measure. Now, the total station is directing the chainman to move 0.949 meters away from the total station. So we'll do the same thing and I'll direct the chainman to move further away from the total station. Once they are further away, I'll measure again and now the total station is directing the chainman to move 6 centimeters behind. We'll do that until the accuracy is 0 centimeters. In our case, we have found K1 by staking out. Now, you can do that for all the other points, K1, K2, K3, K4, K5, K6, and you can mark them using a pin or a paint. In my case, I have used a pin as well. I'll repeat the process for all the 6 points. Now, this is us placing the 6 points, and you have already placed all of them. And that is how you stake out using a total station. We have already staked out all our 6 points, and now we are going to place chalk all around the fountain to get a visual representation of how the fountain looks like on the ground. This is the final output. Thank you for watching this video and see you in the next one.